This is Lab 3 circuits. The goals of this lab are to investigate circuits with resistors and parallels in series and also investigate capacitors. And my findings are listed below as well. Some key concepts are the node rule and the loop rule. Some more key concepts are electrical resistance, which V equals IR, and also equivalent resistance for resistors in parallel, and also equivalent resistance for resistors in series. The final key concept is capacitance, which is measured in farads and is also equal to Q over V, or it's equal to epsilon naught times the area of one of the plates divided by the distance between the two plates. The system is the multimeter and the surroundings of the circuit. Here are my findings from the first circuit. These are some more findings once that the second ammeter has been removed and replaced by a voltmeter. In this part, we measured the change in potential difference across multiple different points of the circuit. In this section, we put an ammeter parallel with the 100 ohm resistor, and this essentially causes the 100 ohm resistor to almost act like it's not there. In this part, we then calculated the resistance values for the resistor, the ammeter, and the wires. Here are our findings from the capacitor section, in which you can see that we charge capacitors and then discharge them using a light bulb. There's probably some error introduced for position and measurement inaccuracies. There's also probably error from the fact that it's a real-life system and not a perfect and ideal system. There also may be timing inaccuracies, specifically regarded to the capacitors, that may impact the results. And we also used a real circuit, not a simulation. The model predicts that if the capacitor was charged with no resistors, that the capacitor would almost instantly reach full charge. However, this does not happen in real life because the wires and the capacitor both have inherent resistance, and therefore it will actually take a little bit longer to charge up because the time constant would then be shifted because of that R value.